Thanks for joining me. Today we're discussing the RS-232 to Wiegand format converter. Now you might be thinking, what would I use this for? Well, let's say, for instance, you had a barcode scanner with an RS-232 output and you needed to interface that to an access control panel that could only accept a Wiegand input. Well, our converter would bridge that gap for you. Now this product consists of two primary parts. One is the controller hardware itself, and the other part is the Windows host software. But before we dive into a live demonstration, let's take a quick peek at the hardware. So looking at the image, if you notice at the far right, there's an RS-232 connector, which is actually a DB9, and that is where you would connect your barcode scanner or card reader or what have you. But you're not limited to RS-232. Because we provide a USB to 232 converter cable, you can actually connect this unit to your PC or laptop. And then now that can become another option for a source of your ASCII input data if you had, let's say, a custom application. And not only could that cable be used for that purpose, but it's also necessary for use with our Windows software that we provide for configuring the unit. And then the other thing I wanted to point out on this image is up at the top where you see option switches. Now, for the most part, you would have probably no need for adjusting those switches, except in the case that you might want to define a custom Wiegand format. By default, the unit locks you into a 26-bit Wiegand format. If you needed something different, a custom format, you would switch on the first switch number 1, to the on position. That unlocks the formatting so that now the unit will accept any format that you so choose as configured in our Windows software. And now you'll notice on the left side of the display, on the lower left, we have a live preview of the converter hardware with the cover removed. And you immediately notice the flashing green indicator, which is sort of a heartbeat that lets us know the converter is alive and operational and it is ready to be commanded. What you may or may not also notice is there's another indicator just to the right of the green. It is red and it illuminates anytime there is a Wiegand conversion underway. And when that occurs, it means there's a series of Wiegand pulses that are being output on the D0 and D1 data lines. Also, for the purposes of our upcoming demonstration, you'll notice another set of indicators over on the right. Those happen to correspond to our USB to RS-232 converter cable. This particular model happens to provide indicator lights corresponding to transmit and receive on the RS-232 interface. So anytime we communicate with that port, either if we're sending Wiegand format commands or if it's being sent ASCII numeric data for conversion, there will be a flurry of activity on those indicators. So definitely something you want to keep an eye on for this demonstration. And this is the application software, of which is available for download, by the way, at the Cadtronics website. At the outset, you'll notice a number of options and selections, beginning with the navigation menu at the upper left. Now, for the most part, those options are all available at the tool buttons on the right. So the uppermost button is where we configure settings. And this is where we configure the COM interface for communicating with the converter itself. The default baud rate is always going to be 9600, although the converter can handle up to 19.2. We do recommend 9600 as that is a more popular baud rate. And then the next selection option is the output report. That is sort of an advanced feature which allows you to examine the bits that are being output from the Wiegand converter. That's something we'll probably get into a little bit later when we get into the test option. And then next is the receive utility, which is sort of a debug and troubleshooting measure for allowing you to communicate directly to your source device, which would be barcode scanner, for example. So if you had any doubt as to what that device is outputting to the converter, you could disconnect it from the converter temporarily, plug it into your PC, and then use this utility to communicate with the device and see exactly what it's outputting. You can see not only displayed characters, but it will also show you any hidden control characters as well. And then next, there is the relay option, which is a sort of an unadvertised feature. The converter unit does actually have an onboard relay. We do not have a defined use for it at this time. However, you are able to control that relay if you so choose, as long as the converter is connected to your host PC. You can command the relay on, off, and there's even a timing option there. And then we have a setup guide, and that is a PDF that you can view at any time. That PDF contains information about setting up the unit, and it contains details as far as option switches, and also contains information about the command and response interface. It has all that detail so that if you wanted, you could actually develop your own complete application. And now our most important set of controls, which would be these tab selections here. There are 3 tabs, in fact. We have input, output, and test. Going back to our input tab, over on the left grouping of controls, we have ASCII source parsing. And here's where you would define what you're expecting to receive from your source device, let's say a badge reader. We're expecting an 8-digit sequence, which would be our ID. And then in this case, it's a position offset of 2. And what that means is the 2 characters preceding the 8-digit ID will be something that we would like to ignore. They are characters of no particular significance. And then we have a special case selection called search character. And search character allows you to define a character that you expect to see before you receive the data sequence. So in this case, we've selected the hash character. Once we receive the hash character, then the converter knows to begin looking for the actual 8-digit ID. And then data validator is another special case. This is actually expected to be found after or following the 8-digit ID. This is definitely a special case in that you would use it in a situation where, for instance, the source device outputs a success fail string. And so $ in this case would be expected to be found in a success situation. So let's say the string would be $GOOD or $good, meaning that the data is considered valid by the source device. If the converter detects this character following the 8-digit ID, it knows to go ahead and proceed with the conversion. If this character is not found, the converter presumes the data is not considered valid and then ignores that data and will not proceed with the conversion. Then the right side grouping of controls, setup and status, is where you can configure a site code. If your intended Wiegand format has a site code, here is where you would define that for the converter. It would be a static number that you can set, and the converter will retain that for as long as necessary. And then below that is a summary of your option switch settings. So as we mentioned before, if you preferred a custom format, which we have done, we've set up a custom format by setting the first switch in the option settings. You enable the first switch that enables custom formats. So we've done that. System is reporting that here. It's also reporting that the converter is configured for a 9600 baud rate and that voltage pull-ups are disabled. And then lastly, the system reports the converter's version, in this case 3.1. And we have restored our live camera preview of the converter hardware. But before we move on, I want to point out a few additional controls on this page. Those would be set, get, and refresh buttons. Now you would use the set button to upload any changes that you've made to the converter settings. So for instance, in ASCII source parsing, if you change the data length and maybe the position offset, you would then use the set button to upload those reassignments. Likewise, over in setup and status, if you change the site code, you would use that respective set button to upload that change. And then the get button does the opposite. It retrieves the settings from the converter so that they can be displayed. And then refresh has the exact same operation as the get button, except that it retrieves all settings globally and repopulates everything at once. And let's navigate to our output tab. Here's where you can define the Wiegand format. Presently we have a 26-bit length. We can increase that all the way up to 99 bits, presuming that custom formats have been enabled with our option switch as discussed prior. Your format can include a site code, it can include ID, and parity bits. Now, we would like to modify the format just to demonstrate that capability. We'll change the bit length to 30. We'll change the ID to 20 bits. And we'll decrease the number of parity bits from 2 bits to 1 bit. And then we'll click the set button. Now in our mini status here, you see that the format has been accepted. And one of the nice features of this converter is that it will try to identify any issues that it finds with your format. In this case, it has found none. But let's just go ahead and demonstrate a potential problem. And the way we'll do that is we'll restore the parity count from 1 back to 2. And the reason this is going to create a problem is because our second parity bit here is located at position 25. But because we've increased our ID code to 20 bits, it now overlaps into that territory. And then now that creates a conflict between the two fields. So let's click the set button. And then now the mini status indicates that corrections are required. In order to see what the error is, we click the verify button. And then down here in the major status, it tells us that the user code overlaps parity 2. So let's restore the format back to the original. We will change the bit length back to 26. We'll take the ID length to 16. And we have 2 parity bits. So we do set. And then now we're back to where we started. And now onto the test button, the test tab. So here's where you have the opportunity to test your format that you've either just set or just modified. So here in the simulate grouping, you can compose a string that would be similar to the output of your source device, or let's say your badge reader. In our case, we have a string that closely resembles the encoding of a magstripe card. Now, What we want, if you recall from the Input tab, we want an 8-digit source, an 8-digit numeric string. And we have an offset of 2, which means we will skip or ignore the first 2 characters. If I go back to the Test tab, I do see that the first 2 characters are non-numeric, which is the reason why we want to skip them. And then we're going to presumably convert the next 8 characters, which would be 1 through 8. So let's go ahead and click Send and see what happens. Now, if we go down to the major status, we see what was converted, which says source equals 1, 2, 3, 4, 5, 6, 7, 8. Now, if there had been a problem, you would see an error instead. So let's just go ahead and modify the string. We'll add a character here. Now, this should be a problem because remember, we're skipping the first 2 characters, and then beginning at the 3rd character, we start our conversion. The letter C is non-numeric, and there's no way that the converter can convert that. So we'll go ahead and click Send to see what happens. So we come down to our major status, and it does indeed report an error. It says invalid source data, and there is that C. And so that is definitely a problem. So we'll go ahead and remove that. And then we'll convert again, we'll send again. Now this time I'd like you to take a look at the preview, the live camera preview, and you'll see some LED activity there indicating that a conversion is taking place. So we'll go ahead and click Send. And the conversion did in fact complete successfully. And the last thing I want to talk about is the output report. Now we've only mentioned that in passing, but I want to show you in detail. This is a pretty handy feature to have for maybe for troubleshooting purposes. It works in conjunction with the simulation that we just did. Anytime we click the send button to send out a Wiegand conversion, uh, the bits that are issued are captured by this Wiegand output window, and they're displayed for you. So we'll go ahead and click send, and you'll see that window updates. Now up at the top of the window, it shows you the source data that was captured, or the source data that was defined, which is 1 through 8, and then it shows you the site code, summarizes also for you the user ID, and then down below that is the mapping, which is the composite bits that represent all of that. And then down here near the bottom, you can modify that representation. You can display a hexadecimal format, and you can also reverse the bits. And then down at bit offset, you can even offset the bits to get a sort of a modified display. So this would be a handy troubleshooting tool. Let's say if you had issues and you weren't getting what you expected, let's say out at the access control panel where your D0 and D1 data lines are connected. Let's say the access control folks are saying that they're not seeing what they expect, and you're saying you are sending what you're supposed to be. Well, this would be a great tool. You pull this out, and then you can identify exactly what bits you're sending and what order you're sending them in. Thanks for joining me for this tutorial. We appreciate you being with us. For more information about the product or to contact us, visit cadtronics.com.